We will give a brief description of our mechanical design and design details. Then we'll progress to some robot facts in our design description. Then we will describe our innovation, programming, and how much fun we had. At the end, Quentin will demo a mission. Here we will describe some basic features of the robots used to perform the missions. We used the LEGO Mindstorm NXT robots with 2 motors that were used for the drivetrain to power 2 large wheels that are 3 inches tall. The third smaller wheel in the back is used to balance and guide the robot. The software used was the LEGO Mindstorm's Education Programming Software version 2.0, but no sensors were used for any of the missions we will demo today. We designed 10 programs using from 3 to 12 kilobytes of memory. The order of completion is based on what needs to be moved to reach other missions. For example, moving the truck to base first, then removing all the fish, including the baby fish, so that there won't be anything in the way of the robot as it makes its way to the pink and green contamination centers. Once the contamination centers are dumped and the bacteria is collected, the baby fish is returned to its position. For all missions, to ensure success, the mission had to be completed 3 times in a row before we moved on. The most consistently completed mission was to collect the fish and return the baby fish because it's easy to align and we can easily send it out again if it misses any fish. The team's favorite mission was to collect the bacteria from contamination centers because of the use of varying acceleration and the collection attachments.
Design process. For the design process, we kept the design simple so that the parts could be easily attached and removed. We tested different tires and learned that the larger tires are not as bulky and allow for reliable repeat performances. We tested the different connectors and sensors, for example, light sensor. We decided against using the light sensors because they were not consistent for every location. For example, at Cindy's house it worked, but at the library it didn't. For innovation, the design that we think is different or a bit more innovative than the other missions is the mission to collect the bacteria. This mission is very cool because of the way the robot changes acceleration to trigger the release mechanism of the containers.
Mechanical design. For the basic structure of robots, we had to change the robot attachments so that there was little assembly required between the missions. The robots used to test missions were all made using the same base and wheels. We had to make sure our missions attachments, including arms, were sturdy so that they wouldn't wobble around or break during the missions. To do this, Max worked to stabilize the wheels to keep them from wobbling. We used
7 minutes.
the collection device that Quentin created for multiple missions, such as collect the bacteria and the rat from the port and putting the baby fish back.
We practiced repeating the position and alignment of the robots. We also took pictures of the placements. We decided to label each program instruction, for example, terms, so that we knew which motor was doing each step. We named the programs by their mission, not by their inventors. We downloaded all the programs to 2 robots, one as backup, in order of their completion. We also prefer using rechargeable battery robots instead of power grids.
Fun. We've had a lot of fun trying different things while working on the challenges. Some of the results have been hilarious. The most interesting aspect about the design is specific to the differences between the robots. Once you figure out the differences, then programming comes.
Trial run. Now we're ready to do our trial run. For this mission, Quentin will demonstrate the program that removes all the bacteria from the containers and brings it back to base.